ends like this, hydrogen is there also. Wherever ends terminal, triple bond is there. Wherever triple bond is there, we will tell ends either that side or this side. That is called terminal alkyne. If I am writing like this is not terminal alkyne because this is not end, middle. So terminal alkyne means it should be end either this side or this side. Understood what I am saying? So I am telling terminal alkyne contain hydrogen only more acidic in nature, then only it will react. You see here one important point I am telling. This is acidic. H2 also acidic nature will be there. But what is the product it is forming? That should be less acidic, then only reaction will occur. This is very important point. More acidic to less acidic. Byproduct is there, the byproduct. That should be less acidic, then only reaction will occur. If it is forming more acidic, that reaction will not, even though it is acid-base reaction. Here you see ammonia is there. When compared to ammonia, this is acidic only. This is base, even though that means less acidic. Base means less acidic. That is reaction occurs. Like that here. So here I will give that one. Acidic nature means with what it will react here. Yes. You write this. Important. So terminal alkyne if you take, if it reacts with NaH or Na, definitely reacts. Why? H2 is weak acid. When compared to acetylene. Here also, when compared to H2 weak acid, so that is the sodium hydride reaction. So sodium it reacts, sodium hydride it reacts, even sodium amide also it reacts. Why? It is weak acid. You see what there is weak acid, weak acid, weak acid. You understood? How the reaction will undergo? From strong acid to weak acid, reaction will undergo. This concept I will tell again, carboxylic acid, then again phenols and alcohols. Very, very important. But you see, it does not react with sodium hydroxide. First you said this is the acid, this is the base. Why it is not reacting? Because water is the byproduct. You know how it is dissociate Na plus, NH2 minus. Here what is coming? H plus. So NH3 formed. NH3 is weak acid. This base is weak acid. That means when compared this one, this is weak acid. So reaction occurs. Only these three reactions they given in our CBS textbook. Sodium, sodium hydride, sodium amide. That's all. So it does not react with sodium hydroxide. It does not have sodium bicarbonate also. Why? H2CO3 will form. That is strong acid when compared to this one. So it is not reacting. Understood what I am feeling? Here what is the byproduct? H2CO3. That is strong acid, so reaction will not happen. Here what is the byproduct? H2O when compared to water. Ethyl is less acidic water. Water only strong acid. Why? Understood what I am feeling? Okay. Very, very important. So with this we can understand they will give alkyne reacts with does not react with like this. So you have to understand not only they will give some other things also, but you should remember only in this case. You know, in this textbook they give sodium and sodium amide. Understand complete here? Like this concept we will study now in carboxylic acid. At that time I will tell again the same concept. Now see, next one, here the point they given. I said no, alkynes are strong acid when compared to, this is alkene, double bond here, double bond here. This is alkene. Terminal alkynes are strong acidic. You see, this is both side terminal. Substituted. When I am substituting acidic nature decreases. So they will give like that in statement type like that. This is the character for acidic nature. That are order for acidic. It's like you should understand that. Alkynes are strongly acidic in nature, but alkanes are not. When substitution occurs, acidic nature decreases. Understood this one first. Next, addition reaction will study. Addition reaction is with hydrogen, with halogen, with hydrogenation, with water. With hydrogen, with halogen, with hydrohalogen, with water. These three things will study, four things will study. So that comes that in all things contain triple bond. So they add up two molecules of dihydrogen, halogen, hydrogen halide, and water. Formation of addition of product takes place according to the following steps. For anything, all these things, first it will occur like this. You understood that? One pi bond will break, one side have one atom, one side one atom attached. But based on what again, you see, hydrogen. This is called vinylic cation. Vinylic cation. So the addition product form depends upon the stability of vinylic cation. So which cation is more stable, that will be existed, and in that place remaining other part will come and attach. Generally, addition in unsymmetrical alkanes, symmetrical alkanes they will not ask question. Any side it can attack same value. Unsymmetrical alkanes, I think you know what is unsymmetrical alkane. Same, if you cut equal parts of the means unsymmetrical or symmetrical. Different parts means unsymmetrical. Unsymmetrical is the general question they ask. Unsymmetrical, what you have to follow? Markovnikov rule. You have the majority of the reactions of alkanes are examples for electrophilic addition reaction. I think dimethyl you are studying from beginning onwards. Any alkane if you take, what will form here? Any alkane if you take, directly it will form alkane. If we use Lendler's catalyst, if we use Betz reduction, cis and trans, possibility is there. That's very, very important. So what is normal reaction? Nickel, palladium, platinum, H2. And rally nickel. So how many triple bonds or double bond is there? That all will break and then never return. If I am using Lendler's catalyst, what is that economic test for PD by C? Or any barium sulfate Lendler's catalyst you will study in those one reduction. So that you have to understand that one. What will from cis? That is self-settled attack. Whether cis will form or not, that is secondary. Self-settled addition. If we use sodium or lithium in liquid ammonia, Betz reduction, and opposite side it will attack trans. Orbital trans will do, but opposite will attack. Like that, we studied that one. Everything I am telling. Next, addition of halogen. This is very important. Addition of halogen. This is asymmetrical. Now, question is, sir, H here will attach, where it will attach, or H here it will attach, where it will attach. That is the question, right? First, what is forming? Vinylic cation is forming. Means here H Z. So H plus will attack first. Positive where it is possible here. Here positive will come, here negative will come. Generally we will like that. But here what is additional halogen? Additional halogen simple. Pi bond is break. Br attached. Any Br same. Another pi bond is break. Br attached. What is forming? 1, 1, 2, 2 tetrabromo-propane it is formed. If we use here zinc, again zinc, that is alcoholic fuels I am not telling. Zinc, ZnBr, then again it will form. But that reaction not given. Preparation of kind they will do. And then 1, 1, 2, so here also reduce orange color of the solution bromine in carbon tetrachloride is called decoloration. Unsaturation test, same here. Understood this? Addition of halogen, simple double bond break, other bond is break, finally we can get Br, tetrabromo. Next, addition of hydrogen halide. Here the question is for unsymmetrical alkane, this is symmetrical. There is no problem here. Because you see, here I am attaching hydrogen, here I am attaching Br. This is vinyl bromide. Vinyl bromide it is formed. Means bromine containing lone pair, single, double. That is, it is a partial double bond characteristic. Now the question is here, again this bond is breaking. Understood? Again this bond is HBr has to attack. Where H attack and Br will attack? That is the question. Understand what I mean? Here positive charge is forming this Br here will attack. Here negative H is attacking and again Br attacking here. Why like that? Why like that? Addition of hydrogen, latest catalyst and all the things. Addition of halogen, you understood? All the breaking tetrahalide is forming. Simple here. Triple bond, double bond is break and Br there attached. You understood this one? Now this one is hydrogen halide. What will form here? Positive, negative. So positive, negative will attack and this will attack. With that, what is forming here? First, there is no real element here. You should remember that. So after attacking H plus, it is forming. With this H minus attacking, here it is formed. Okay, understood? Now the question is here. Now, here negative, here positive. Here negative, here positive. So positive here getting means easily that again X will come and attack here. So we are getting geminal dihalide is formed. What is the reason? So you can ask one question, sir. Here positive, if you make electron withdrawing group, stability decreases. Don't tell here. What is happening here? Bond, back bonding concept. Back bonding concept. What is that back bonding concept? Here, carbocation means empty p orbital is there. So here, this will occur. That is in back bonding. That's what I think. So due to back bonding, no rearrangement. The only both state. So that is the reason here. Actually, you can tell, sir, minus side group attached, carbocation stability decreases. But here, back bonding comes. That is the reason I what which type of carbon forming geminal dihalide is formed. Get it out. First you remember this one. Where H plus is attached. Positive H. So there after that secondary there is no rearrangement here. And we are getting here halogen. Then no rearrangement because back bonding. There only other halogen commanded. But you see, Marconic addition, what is Marconic addition? Where less number of hydrogen, there negative part commanded. Again, where less number of hydrogen, negative part commanded. Like that, Marconic is following like this. Okay. Same manner, here also we tell CH3, CBr, CBr, CH2, CH3, that's all. Same manner. Direct method. Now, addition of water. This is very, very important. Addition of water. Very, very important. Which are the reaction? Reagent is what now? Dilute H2O, dilute mercury sulfate. 1 to 2%. Or like this also they have which is 2 plus by H2. Okay. In serious textbook, what they given? Like alkanes and alkenes. Alkanes are also invisible and do not react with water. One molecule of water adds to alkanes on warming with mercury sulfate and dilute sulfuric acid. On forming with mercuric sulfate and dilute sulfuric acid, or Hg2 plus by H plus delta. HO is only reacting. But where OH attacking, where H attacking, for this one no need to ask. But after attacking, this will be vinyl alcohol. I will tell this is enol. Enol. It will become catholyl. Isomerization that is. Isomerization. Then aldehyde is formed. You can see here, very important. Here aldehyde forming. Other than ethane, anything you take, it will form ketone. Why? You see. Here OH, here H. Here OH, here H, it is formed. Negative part will attach less number of hydrogen. OH attack and H attack. Enol. Enol, what will form? H will go here, double bond will come here, ketone will form. Isomerization. This is catone. Catone will be not whenever is less stable when compared to ketone. So, what is the important point here? Only ethyl forming aldehyde. Other than ethyl, anything if you take, it will form ketone. Anything you take, it will form ketone. Some ketone. So this also we will study in preparation of aldehyde ketones. This property becomes preparation there. Understood already? Next, polymerization. Linear polymerization. There are two types of polymerization: linear polymerization, cyclic polymerization. Linear polymerization, already polymerization is I am taking ethane. Ethane comes ending into high temperature pressure with catalyst. What will form? Ethane will combine to form like this. Takes place to produce polyacetylene will form. Acetylene will take polyacetylene. Or polyethylene also will take, which is a high molecular weight polyethylene containing repeating units and can be represented like this. Under special condition, it conducts a polymer, conducts a plastic, conducts this one. Why like that? You see, unsaturation is continuously means entire polymer, entire molecule, double single, double single, double single. So the pi electrons are moving, mobility of electrons, conduction of electrons. Like this. So reaction not given, but you see here how it is formed. Polymerization. Okay. Next, cyclic polymerization. This is important reaction because we will take here ethane, preparation of benzene. 3 moles of ethane we are taking, send to red hot iron tube. When ethane sent to red hot iron tube, what will get? Benzene will form. How? This is called diene sorter reaction also they will tell. Coupling, cyclic coupling they are telling that also. See, triple bond, here bond, E triple bond, here triple bond. So remaining double bond, it will form benzene. Simple. Understood what I'm saying? So when I'm sending 3 moles of acetylene to red hot iron tube, then what will form? Benzene will form. So for understanding what they are taking like this, you see here. Here, this is forming here single bond. This will form here single bond. This will form here single bond. Means here what is there? C H C H C H CHF, CHF, CHF. That means here we are getting double bond C, C, H. Here single bond forming, here single bond forming. Here C, H, here double bond is remained. Here C, H, double single bond remained. Here C, H, here double bond is formed. Here C, H, here C, H. So bending. Understand? This bond here, one bond here, one bond here. So bending. Like this, any alkyne if you send 3 moles, red hot iron corresponding aromatic component is forming. If I am taking propane, you see, interestingly, what will form? Mesitylene we will tell means 1 comma 3 comma 5 trimethyl benzene forming. 1 comma 3 comma 5 trimethyl benzene is called mesitylene. You know, 2 CH3 groups means xylene, XYLEN, orthoxylene, metazine. 3 CH3 alternative is there means mesitylene, very very important, they lost this. What is mesitylene? MESITYLENE. 1 comma 3 comma 5 trimethyl benzene is called mesitylene. Mesitylene. It is from 3 moles of propane. It is formed. Understood why CH3 is there now? Instead of hydrogen, CH3 is there. That is the reason it is formed. For example, if I am taking here in this place another CH3 means due to ion. Here what is formed? CH3. Oh, sorry. Here CH3. Here CH3. Here CH3 will come. All CH3 will come. What? Wherever hydrogen is there, CH3 will come. All CH3 is there. Like that. I think they given. Not given. Okay. But now you can tell here reaction. First you tell me this. Here what is forming? Firstly, acid reacts with base, salt will form. Soda lime I am reacting. Soda lime means NaO, CaO. NaOH, CaO. What will form? Soda lime means one carbon less. I said at that time. Hydrogen atoms. Here more halogenation. CH3, CH. Here CH3, CH. Here CH3, CH2, Br. Alcoholic OH. CH2 double bond, CH2. Br2 by CCl. What will form? What will form? Tell me. Oh, fine. Here what will form? Here what is forming? CH2, CH. Now CH2, Br form. Alcoholic OH, HBr removing one double bond, NaBH another double bond. Totally, what will form? Alkyne. Alkyne RH2 if you do, benzene. Just how acetic acid converted to benzene. Like this only converted to benzene. So, question is this one, how to convert like that? How will we convert acetic acid into benzene? You have to make like this. Got it? I'll tell you this one question. CaOC, what will form? Calcium carbide. Hydroxys. IHT means red hot iron tube. Benzene. Now see, with this one equivalent sodium, that one what will form? One equivalent means sodium ethyl. Now see, sodium salt of D, NaOCO, benzene has to form. Oh, very good. You understood that much? What I'm saying? About detail. Benzene has to form. What is this name reaction? Soda lime. Soda lime is what? You take hydrogen, remove that hydrogen and keep CO. Sodium. Salt. That also salt only, but that is definitely how to take like this. Why? You know that Na2CO3, H attack. H attack moving. Don't, sir, hero, say. Soda lime means what? Those are the whole electrolysis and the soda lime. Whole electrolysis means what? COH attack, remove. Remaining one dark you keep, like which reaction image attach. Soda lime means COH remove, hydrogen attach. Yes, sir. Any doubt? Tell me this one first. Yes, you understood this one I am giving here. What will form now? Like this it will form. Dr. Alkali NaH2, here what will form? Triple bond. This is all. Definitely what will form? All side. Yes, very good. All side. Okay. This one Hg2 plus Hg2, what will form? First here one OH double bond will form. Then how it will exist? Double bond will exist. This is formed. Anon isomercury. Mercury. Then directly this one lithium liquid ammonia. Lithium liquid ammonia, what will form? Trans will form. Outside, lithium liquid ammonia, trans will form. Then ozonolysis, they did ozonolysis, then what will form? OO means 2 moles of CH3, C double bond OH. Okay. Get a next one. Now, see D plus Cl minus, two equivalent, same thing, it one side it will attach, D one side it will attach Cl. Correct? Another side D, another side Cl, like this. Two equivalents on in like Gemini. Okay. So in this alkyne chemical properties completed. Now see benzene. Aromatic hydrocarbons. The hydrocarbons also known as arenes. Most of them possess pleasant odor. That is the reason why we take aromatic scent. But actually, if you go in any laboratory, chemistry laboratory, smell is not nice. But actually, how will tell that means sooty flame that is aromatic. But long carbon chain containing also it will give sooty flame. So most of such compounds were found containing benzene ring. Benzene ring is highly unsaturated, but in majority of the reactions of aromatic compounds, the unsaturation of benzene ring is retained. However, there are examples of aromatic hydrocarbons which do not contain a benzene ring, but instead contain other highly unsaturated rings. Aromatic compounds containing benzene ring are known as benzenoids. You know what are non-benzenoids? Like that. They are all benzenoids, aromatic. Benzene, toluene, naphthalene, biphenyl aromatic compounds. So nomenclature and isomerism means generally they will use. You see this one with the name. How they will use? Methyl benzene. 1,2 dimethyl benzene. This is called argoxylene. You know, toluene. Beta, that is metaxylene. 1,3. Terrazine. 1,4. Like this names we are giving. Oh, but with that only they remove. Now, structural thinking concept is very, very important. That to find out this structure it is not easy because you know structure how they will find at that time by doing some reaction. Okay, here unsaturation is there. Bromine is decolorization. Or if you calculate formula, du if you calculate, you know one compound we are getting now we will extract by using all the methods carbon how much percentage, hydrogen how much percentage, like that formula. That formula by using that formula du how much you can get it from the du here will come more billion. Means what? Initially what they will think okay, it may be 4 double bonds. It may be 2 triple bonds. Like possibilities they will give them. But when they are doing reactions, okay, here double bond not there, okay, here triple bond not there. Like this, they will come an idea. Like that they will do. But benzene was isolated by Michael Faraday in 1825. The molecular formula of benzene is one is correct. It is a high degree of unsaturation. Degree of unsaturation how much? 4. This molecular formula did not account for the relationship to corresponding alkanes. So this is not CnH2n plus CnH2n, not CnH2n minus 2. So it is not alkene, not alkene, not alkene. And what do you think about the particle structure? If you write like this, there are so many particle structure you can write. I write hexane to total 4 double bonds somewhere. That may be answer like that we can. So like that, due to the unique properties and unusual stability, it took several years to assign this structure. Benzene was found to be stable molecule and found to form triozonoid, which indicates the presence of 3 double bonds. They understood ozonosis, they don't. What will form? Triozonoid will form. Ozonoid is what I said. 2 oxygen, like this, I'm given a like that. 3 triozonoid forming is, they understood that one. There are 3 triple bonds. Means a ring form. Like, so benzene was further found to produce one and only one monosubstituted derivatives. So only one type of substitutional occurring, which indicated that all 6 carbon and 6 hydrogen atoms of benzene are identical. So they understood all hydrogens are same. On the basis of this observation, August Kepler in 1865 proposed the following structure of benzene having cyclic arrangement of 6 carbon atoms with alternate single and double bonds and one hydrogen atom attached to each carbon. Kepler, this fellow, he got the money in his dream that one snake it is eating its tail. So ring form may exist benzene like that. And that's what I think. Several years takes structure. They are not able to find out by doing reaction differently, showing that how we can examine that one, this type of structure is there like that. Nowadays, spectroscopy is there. So you keep that one, all the types of bonds it will tell. At that time, not there. Small amounts, pinch of salt, they will take and they will do so many reactions. Not easy. Correct or not? What is it? So he is telling, what you can study this one. See, a long row sometimes more closely fitted together, all twisting and turning in snake-like motion. So he is doing always that experiment, he's sleeping, then he got sleep. That bring he got that idea. Understood? I spent the rest of the night working out the consequences of the hypothetical and then to read the internet. Something is telling. There are so many types of structures that are not given here, but here the important point is normal modus operandi is same type forming. If I am taking bromine disubstitution, the technical structure indicates that the possibility of two isomeric compounds are. I am talking about disubstitution to isomeric compounds. When the substitution occurs, double bond may occur. When the substitution double bond may not occur. Like that, these two types will come. You see, different. So bromine, between two bromine carbon, no double bond. But between two bromine, double bond. These were different. So our benzene was found to form only one ortho disubstitute. Only one type of ortho disubstitute only is found. This problem was overcome by Kepler suggesting that the concept of oscillating nature. This is resonance. That is not true double bond. That is not true single bond. Because double bond length already I said, triple bond length already I said, single bond length 154. But 154 not coming single bond. All carbon bonds are same length coming. That is not double bond. That is not single bond. Between that coming. Understood? So that is in resonance. That they said it is in existing level. So even with this modification, chemical structure of the engine fails to explain unusual stability and preference to substitution reaction than addition. It's a double bond is there and the addition reaction as well. But substitution only it is happening, like to that. So resonance and stability of benzene ring, you understood this part. How it is forming, you know, sp2, 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 sp2. All are sp2 hybridization. That means 1 pair of them, 1 pair of them, 1 pair of them. Every carbon has 1 pair of them. So 1 pair, 1 pair, 1 by 1, 1 by 1. So how it is existing, you know? Sandwich type. Sandwich type. Up and down by 1, like that. By using X-ray analysis, X-ray diffraction, they observed electron cloud is up and down. Understood what I mean? So the 6 electrons of the D low electron can move freely about 6 carbon instead of D2. So the D low electron cloud is attracted the most strongly by the nuclear of carbon atom. They are electron cloud development between two carbon. So therefore, presence of D low electron in benzene makes more stable than the hypothetical cyclohexatriene. Okay, cyclohexatriene, why they are giving here? If you want to give name for benzene, I want to give name for benzene. What will be sir? Cyclohexane, sir. Alternatively double bond, sir. So 1 comma 3 comma 5 triene. Cyclohexa 1 comma 3 comma 5 triene. Can I tell like that? That is like cyclohexatriene. But actually cyclohexatriene, if you take that energy, benzene energy differently. By some energy utilized to move. That is called resonance energy. This concept I will tell in thermodynamics. Actually, resonance energy will be there. Normal cyclohexatriene is different. This one is different. Existing. The reason is those bioreactors are not stationary. So X-ray diffraction data reveals that benzene is planar molecule. Had any one of the above structures of benzene been correct, two types of CC bond length were respected. I said that. 151 number 3. But it's not coming like that. How much coming? 139, which is intermediate between single bond and double. It is not a true double bond. It is not a true single bond. When this carbon will come, what will come? Resonance. What is the resonance? You know, a structure, a molecule will contain two or more structures. None of these structures explain all the properties. A structure which explains all the properties. That is hybrid. What is the hybrid here? That is the reason we will write like from middle. Alternate double bond will write middle by they are not stationary. Okay. Now aromatic means no need to tell already I explained. What is aromatic? four important groups: cyclic, planar, conjugation, 4 and plus 2. When n is 0, 1, 2, 3. How will you tell cyclic? Small children will tell cyclic. Second, how will you tell planar? sp2 hybridization. Planar. How will you confirm delocalization? That is very important. Rhythmically, how to tell. Lone pair, single, double, double, single, double. Everything you have to consider. That localizing. That is relocalization. Conjugation. After that, finally, how many pi electrons? Not only pi bonds. Sometimes low pair also involved in them. That low pair also you have to consider the pi electrons. Understood what I mean? Because you see here, this one is there. Negative charge, low pair. Low pair single double, it is undergoing resonance now. That means by seeing like this, filters are one pi bond and two electrons, or other pi bond, two electrons, total four pi electrons. But this lone pair is involved in resonance, so total six pi electrons. That one. So six pi electron means in 4n plus 2, n is equal to 0 means 2 pi, n is equal to 1 means 6 pi. Don't confuse. 4n plus 2 until row. N is for aromatic 0, 1, 2. For anti-aromatic 4n pi rule, everything same. But Akil number 4n pi rule, N is 1, 2, 3. Means 4 pi, 8 pi, 1 pi, 4 1 4, 4 2 8, 4 3 1. But anti-aromatic. So what is non-aromatic? First three rules, any one rule is not obeyed. That is not. Understood that one? So that topic also there in Geos. Next here, preparation of benzene. There are three important reactions they will give. Three important reactions. Already one reaction you studied cyclic polymerization of ethane. When I am sending 3 moles of ethane, red hot air should be get benzene. This is decarbonization of aromatic acid. Where we studied this one, soda lime, preparation of alkanes, same reaction. But I want here hydrogen of CONA. See, for example, here is, if I want to prepare toluene, what I will take? Everything gone, hydrogen attached, toluene. Are you getting up? There you go. Like it. Half of xylene has to get. Just for understanding, I am telling. Okay, so another reaction, decarbonization of aromatic acid, that is soda lime reaction. Understand what I am telling? Every time I will tell for understanding. Because you confuse post electrolysis, decarbonization, don't confuse. Reagent is different. Check. On this attached, it's attached. Again, carbon don't keep like that. Now, this is very important. You will study again chemical property of phenol. Phenol reacts with zinc dust. Then what will come up? Zn will remove, H will attach. Zinc oxide. That's all. Direction of phenol. That's what I simple reaction. So, first one, ethyl preparation, from ethyl we have to make polymerization. Decarbonization, sodium salt of carboxylic acid, that is, what is the name you will tell them? Sodium salt of, that is, sodium benzoate. The name is sodium benzoate. So, sodium benzoate, if you take the sodium and reaction, then we get it. Here, phenol reacts with Gibbs dust, it will form benzene. You know this OH, resource now. Cat. OHCH3, Cresa, CRESYL. Names, different names. I'm telling. You have to remember that. Just okay, that I'm taking. Okay, next properties, physical properties. You know, aromatic hydrocarbons are non-polar molecules and are usually colorless liquids or solids with characteristic aroma. You are also familiar with the naphthalene balls. You know naphthalene balls. Naphthalene means two bending rings. Two bending rings. Three bending rings, anthracene. One bending ring, two bending ring, naphthalene. Anthracene. So that naphthalene balls which are used in toilets and for preservation of cloth because of unique smell of the compound and the most repellent property. Those will not come. Aromatic hydrocarbons are nowadays also we are keeping in your visual this that smell. When I'm going my hometown, my sister kept this so much naphthalene balls. When I'm wearing naphthalene coming, smell. Right? But see here one important point, aromatic hydrocarbons are invisible with water but are readily visible with organic solvent. One of the tests you will do, you know, in your laboratory. Is it aromatic or not? By taking picture of that one, the Bunsen flame, in heat, sodium flame from these get aromatic or unaromatic. So definitely these will tell sodium flame. Point. Next, chemical properties here now. Here, let's take our properties instead first time we go. Electrophilic substitution reaction we study. There are 5 important will be there. After that, we will study here addition reaction we will study. Combustion reaction we will study. That's all. 3 reactions. Electrophilic substitution, addition, combustion. But they will tell like this only. There are so many things are there to tell. Okay. So first one, I am taking electrophilic substitution reaction. Electrophilic substitution reactions. What it is undergoing electrophilic substitution? Generally, number one is addition reaction. The reason is here the common electrophilic reaction, nitration, halogenation, sulfonation, freedom from alkylation, freedom from acylation. Then we can get electrophile. Common item. That's simple. Simply if you want to tell here, total nitration, halogenation. For halogenation, now benzene is the reactant. Halogenation means what is the reaction, you know? FeCl3 anhydrous or AlCl3 like that. Means Lewis acid, in the presence of Lewis acid, reacts with Cl. Very important. Anhydrous, AlCl3 like that. If you take, there are Lewis acids in the presence of this one, halogenation occurs. In the presence of this one, halogenation occurs. Understood? See what they given? Anhydrous AlCl3. Cl2. Very important. You see, if I am not giving anhydrous AlCl3, if I am giving HNO, addition reaction. Addition reaction. So many points are there to tell. Simply first remember halogenation, what is the reagent? Nitration, what is the reagent? Sulfonation, what is the reagent? Alkylation reagent, acylation reagent. In that reagent, which is electrophile, that also you have to know. In halogenation, what is electrophile? Cl plus is electrophile. Cl plus Cl to be Cl2, Br to be Br plus. That will come on attack. Here, what is the actual hydrogen is there? Another Cl, this Cl going to. Simple. But reagent is very important. Anhydrous Cl3 in the presence of Cl2. Then only substitution reaction. Halogenation, what is electrophile? X plus. X means Cl plus Br plus. Like that, for nitration, very important. Concentrated HNO3, concentrated HNO3 and concentrated H2S. These are nitration mixture. But HNO4 nitration mixture. Very important here. What the electrophile means? NO2 plus electrophile. NO2 plus the electrophile. So, in our C-based textbook, what they given? Common mode causes at this temperature, then what is attacking. Your right one is going, OH will attack H2O form. This mechanism I will tell. For each and everything mechanism is important. First you have to remember, nitrogen is a nitro group attacks. Halogenation, what is the reagent? Cl pellet. Like that, sulfonation, very important. Sulfonation, they are giving here you see, concentrated sulfuric acid or oleum. Oleum means H2S2O7 also. They will give three things: concentrated SO4, fuming sulfuric acid, H2S2O7 or oleum. Like this also they will do. H2SO4, SO3. If you add SO3, what it will become? H2S3S2O7. H2S2O7. That is fuming sulfuric acid. Oleum, concentrated sulfuric acid. Like this. But here, electrophile is very, very different. SO3, there is no charge. This is neutral electrophile. SO3 is the electrophile. In sulfonation, what is the electrophile? SO3. Very, very important. It is the neutral electrophile. So that SO3H it is forming, OH reacting and it is forming H2O here also. Benzene sulfonic acid. Chlorobenzene, nitrobenzene. Nitration, nitrobenzene. Chlorination, chlorobenzene. Sulfonation, benzene sulfonic acid. Understood? Next, Predominant alkylation, scientist name. And predominant acylation. Reagent is what we see. Anhydrous CHCl3. Anhydrous CHCl3. The very CH3Cl. Very important. This so much thing is there to tell. I will discuss that. Anhydrous CHCl. What is the electrophile here? CH3 plus. So they will give here RX type. R means methyl or ethyl type. Friedel-Crafts alkylation, this is the reagent. RX anhydrous ClCl. Definitely this is needed, very important. If you take like this, Friedel-Crafts acylation, acetyl chloride, CH3COCl, RCOCl, anhydrous aluminum chloride, same. What is the L profile here? CH3CO plus is the L profile. CH3CO plus is the L profile. So nitration NO2 plus is the L profile. In sulfonation, H2S2O7 or common rated sulfuric acid like that. SO3 is the L profile. If it is like that, Friedel-Crafts alkylation. What is the reagent? For understanding, I am writing RCl, anhydrous aluminum chloride. What is the L profile? R plus. Carbocation. Carbocation. Friedel-Crafts acylation. Acylation. What is that? RCOCl. In the presence of anhydrous ClCl3. You know, here what is the profile? Acyl RC double bond plus. There is no rearrangement here. Here rearrangement is possible. Very important. So like that, 5 reactions. This will come on attack. And what is the byproduct here? H is there, Cl is there, H is there, Cl is there, it will go. Here H2O, here H2O, here HCl. Name, reagent, what is forming? In nitration, nitrobenzene form. In halogenation, chlorobenzene, bromobenzene will form. In sulfonation, benzene sulfuric acid is forming. In acylation, alkyl benzene will form. In alkylation, alkyl benzene. In acylation, acyl benzene means here acyl means ketone will form. Ketone. You see here how ketone will form. You understand now? C double bond attacking now. So it is methyl phenyl ketone or acetophenone, or we can give one phenyl ethane 2 one. Sorry, 1 mole. 2 carbons. This is phenyl. Like 1 2. Here 1 more coming. Check it. Acetophenone. Or if we use acetic anhydride also, either acetyl chloride or acetic anhydride. Acetyl chloride or acetic anhydride. We can get COCH. CH3COH is small. CH3CO plus, that is the electrophile. If excess of electrophilic reagent is used, further substitution reaction may take place in which other hydrogen atoms of benzene ring may also be successfully replaced by electrophile. For example, here important point I am doing this. I am doing Cl2, monohalogenation. Excess Cl2 I am doing. In the presence of anhydrous Cl3, what will have other hydrogen replace Cl, other hydrogen replace Cl, other hydrogen replace Cl. Like this, what is forming here? This is called hexachlorobenzene. HCB, hexachlorobenzene. C6Cl6 will do. Very, very important. Don't confuse, I will tell. When I am telling other reaction, you will confuse. If I am using excess chlorine anhydrous ClCl3, then all the hydrogens substituted by chlorine, hexachlorobenzene forming C6Cl6. Now mechanism we will discuss for each and everything. First, if we see, first what will form the electrophilic generation, formation of carbocation intermediate, removal of protons from the carbocation. 3 steps will be there for each and every mechanism. taking, you see here, generation of electrophile for, you see here the given. The prince are Cl plus, R plus, RCO plus are the electrophiles. But for halogenation, if we take like that, what is happening? First generation of electrophile. For halogenation, I am giving Cl2, AlCl3. One Cl it is because aluminum is here, you know, here aluminum is not uptake. It has able to take Cl. Then AlCl4 minus will form. Then it will form Cl plus. This is only chloronium ion, that only electrophile for halogenation. For reduction of alkylation, CH3 plus AlCl4 minus. Same CH3 plus carbocation. There is a positive rearrangement. Here rearrangement is positive, you write. Rearrangement is positive. I am taking CH3, CH2, no rearrangement, CH3, no rearrangement. But propane plus rearrangement of here. Understood? Here no rearrangement, CH3, C double bond over, that only another profile. So there are generation of electron for each and every reaction. First step for halogenation, first step for alkylation, first step for acylation. What is formed? Electrophiles are formed. In case of nitration, what is the reaction? This is very important. HNO or H2SO4. Both are acids only, but which is strong acid? H2SO4 strong acid. If you remember, two strong acids are. In that one is strong acid, means this will become base. Understand? So base means HNO3 will give OH minus. So HNO3 becomes OH minus NO2 plus. H2S4 will give one H plus and HSO4 minus. On H plus OH minus H2O will form. Are you getting that? Like this here reaction I am writing this. In this reaction, which is base, HNO3 base, which is acid, H2S4 acid. So like that. At the time, if I nephew would be added my number, all that engineering people will come. You will join or join. How can I join? Yes. Okay. The very important this reaction again the last question. Now see here what is happening. HNO3 OH removed indirectly. It is what is forming HSO4 minus H plus attack. Here you see now water molecule removed here and NO2 plus will form. So nitronium ion. This is generation of electrophile for nitration stimuli. Finally, what is coming? Tell me. HS4 minus is there. H2O, okay. NO2 plus. Now this will go and attack. Here, it will go and attack. It will go and attack. It will go and attack. Electrophile will go and attack. Second step. First generation of electrophile. Formation of carboxyl intermediate C's. Electrophile come here Cl plus you take, CH3CO plus you take, CH3 plus you take, NO2 plus you take, anything you take. What is happening? See. This is just a mechanism, how it is existing like that. So more stabilizing now. L profile attacking. Now, when L profile come and attack, here what is their hydrogen is there? Everywhere hydrogen is there. Just for them understanding, they are giving here hydrogen. Okay. L profile attack, double bond is here shifting. So negative charge coming. So E plus will attack. Here negative charge means here positive, that positive. Like this, it will arrange. You see now. 5 bond convert to negative. Here double bond will form. Here positive charge. Here is. Again 5 bond come negative. Here 5 bond, here positive charge will come. So like this it is rotating, more stabilized. Finally here you see removal of proton from the carbocation intermediate. This is intermediate now. If you take halogenation, here what is the CLA? If you take alkylation here CH3, acylation here COCH3, nitration here NO2. Same. So like that, if I am taking here, you see, removal of proton. AlCl4 is coming, whether it is halogenation, alkylation or acylation. Then what will happen, Anna? Here E plus is removing. No, not E, hydrogen is removing. And the hydrogen will go and attack here. AlCl3 itself will form. Or it takes CH3. Okay. Hydrogen is going AlCl3, CH3 attack. Here COCH3 is there. H will go HCl plus AlCl3 will form. Third step, removal of proton. But sulfonation is very different. In sulfonation, I think not given generation of sulfonation not given. Sulfonation is different. Why? It is not charged one, neutral alcohol, SO3 alcohol. First SO3 come and attack. Nitration, it is forming. Halogenation, forming in the sulfonation. So when I am taking here SO3 H plus 4, either methyl S4, female H plus 4 or only SO3 common attack. Just for understanding, they are telling that this benzene sulfuric acid. SO3 minus will form. And fourth step also will occur sulfonation. Fourth step also, here H plus common attack, we are getting benzene sulfuric acid. Okay, I think you understood alkylation, acylation. But you see, alkylation, they may give ROH plus or CH3Cl, RH plus AlCl3 or RCH2 by H plus also. Because in all the cases, carbocation will form now. I am giving the H plus alcohol, OH remove, positive they attach, there are the carbocation. Rearrangement is possible. Very, very important now. What I want to tell, if you take like this, you see, reaction. I am giving benzene, I am taking CH3Cl, anhydrous AlCl3. Understand what I am saying? You see here. You see here. Very important because students will confuse here. I am taking CH3Cl, definitely what will form? Toluene will form. What is here? That means AlCl3 acts as catalyst here. Same LC is forming when product in reaction mechanism. If I am taking here CH2, if I am taking here CH3, CH2Cl, now what will form? This is positive charge. That is that. That means CH2. What will form? Ethyl benzene. Here methyl benzene. Understand what I'm telling? If I am taking like this here, you see CH3, CH2, CH2. Here what will form? Methyl benzene, ethyl benzene. Here that will not form. What you are telling? Propyl benzene, sir. That will not form. Very important. Very important. Methyl benzene, methyl chloride, methyl benzene forming, methyl chloride, methyl benzene forming, propyl benzene will follow. The reason is here positive charge carbocation, any rearrangement? No. Here carbon, any rearrangement? No. Here carbocation coming na. Now this positive here, hydrogen here, isopropyl. That is like this is called cumene. Isopropyl benzene, cumene, or yellow name, what the name? Propyl propane. Understand what I mean? Propyl propane will form. Very important. So many students they will do mistake. This carbon concept they don't know. No. I'm getting another like this. Methyl chloride, methyl benzene. Methyl chloride, methyl benzene. Propyl propane benzene. Some are difficulty they want to ask questions here. They will give like this. You see. If I am giving like this, what? Now question is here chlorine removed. Positive charge formed. Now here 3 plus 1. If hydrogen here, positive charge here, 3 plus 3 plus 2. So that means now on benzene, which is going to attack, you know? This is going to attack. Are you getting all? Here attaching one option, here attaching one option, here attaching one option. Then it is. Understood what I mean? Rearrangement will occur from cradle cross acylation, alkylation reaction. Cradle cross alkylation rearrangement will occur. Okay, carbocation rearrangement. Okay, cradle cross acylation, no rearrangement. Why? Backbonding. Here no rearrangement. Wherever CO is there, that only bring a attach. How much big thing is there? No point. No rearrangement. Understood this point? Aromatic ketone will form. Okay, next class I will explain this one. But so up to now, what I said, only electrochemical reaction I said. All the mechanisms, what are the electrophiles, what are the products, where rearrangement is possible, cradle cross alkylation. Very big. Not only CH3Cl and NH2ClCl3, they will give alcohol and H plus acid also. Alkene and acid also. In that study, alkene. There are carbohydrate rearrangement on that one. Don't get. Okay. I think post reaction like that bending aldehyde formation. You study bending. That is chemical property we can tell. That is rate of acylation type only, but HCH won't like that. Benzol degrade. Right? You know? So I will discuss remaining topics, but a very important topic. This one I will complete that. With this we can complete this hydrocarbon. Next we will start separately. Tomorrow, 7 to 7:30 this repeat from the 8:30 use that. After that, I will keep a solution question.